As you can see, the barometer is reading, numbers are changing, and if I blow down the pipe I've connected to the boost stub, that's all connected. I've got lights flickering there, don't know if you can see that. I've got a light on the front. So that's a surprise, but good. Hello, new experiment, totally different subject. I've got some new software for my rolling road and I needed to generate some sort of pulse creation. So I've adapted a kitchen item to see if it'll do the job. Have a look. So I've got a Kenwood chef of 19 god knows what vintage, got it off Freegal, and I've created a toothed wheel adaptation which goes on where the liquidizer thing used to go. This is held on by friction, so hopefully it'll be right. Little pickup, cable runs down, and I've connected it into my oscilloscope. So I shall put you on the tripod and go and turn the machine on. We can see what happens. Okay, I have no idea if this is going to work. Nothing. Ah! That's what we want. How cool is that? Classic. So, next stop is to see what frequency that is. I'll back with that. Right, I've never used this before. It's another thing I found down the scrapyard and fixed up. So I'm going to see if I can get a frequency measurement. Right, I appear to have worked this out. So let me turn it on and watch these numbers. So that's the frequency in kilohertz. That's position 1. Position 2. 3, 4, 5, 6, 7. So how cool is that? I'm chuffed to bits with that. So now I can simulate different road speeds and have a play. Ciao for now. Okay, second test. I've hooked up my pulse generator over here, which is a Kenwood Chef food mixer with a toothed wheel bolted on the liquidizer and a pickup on there. I've got that hooked up to the input port on the tap box, and I'm going to turn it on, and if it works, this graph here is going to start showing us a waveform, or a power curve really. So I'll zoom in. zoom in. There we go. Zoom out a bit. Let's see what happens. Well, that seems to have done something. File name. Oh. Okay, well, I appear to have simulated perhaps a trifle more power than I'm likely to get on my rolling road. 739.7 bhp at 5,650 rpm. And we've got 3 interesting graphs there. What's that thing saying? Differences due to power loss calculation greater than 1% of max power. Check if calculation is correct. Oh, no idea what that's all about. Differences due to power loss. Ah, gotcha. Well, that seems to work. Okay, so we know we've got the pulse going in the right place in the box, and we're making a calculation based on pickup RPM. So that's good. Let's just do another one. And let's turn this on. That should show us a waveform as well. Okay, let's do another one. Okay, I solved that. It didn't like having that analytical graph program running at the same time. So I'm now also going to zoom out a touch, because I've got the digital counter showing the pulse frequency that we're putting into the machine here, which I thought might be handy to know. If I can get them both on the screen at the same time. There we go. Well, let's do a new one. Let's go F12. Conduct yes. I should have cleared. There we go, F10 start. Right, we should be ready to go. I'll try and do a smoother acceleration run this time. I should have confused the hell out of it. Yeah. I better zoom in on that just for posterity. Yeah, that'll be my mini then. Okie dokie. So we're making graphs, and it all seems to make sense. 2,132 bhp, 0.5, 5,400. What's not to like? Okay then, and we measured frequency on that video so I can look that back at slow motion. What else do I want to try? Oh yes, I want to try working out what the inputs are. Ah, this thing keeps kicking in. (2,100 bhp). Look at that torque. 2,800 pounds-foot of torque. Sorry, 2,759 pounds-foot of torque. Nice. Right, I wonder if I close that, will this work now? Yes, it will. So I have to close that for this to be live. Okay then, so now I want to have a look and see if I can find out what inputs are allocated to what channel numbers. So I'm going to put this, I'm going to close this and open it up with it much closer to the screen. Right, I'm going to move this temperature sensor down the channels so I can see what there is changing in this section. Okay, so I'm going to plug it into, what are my numbers? That goes there. Okay, so I'm plugging the temperature sensor into channel number 2. Nothing changing in there. Nope. Oh, actually I want to be on live update, don't I? Oh! There we go. Okay, we're all zeroed. So let's just plop this in there. Nothing on number 2. Nothing on number 3. Nothing on number 4. Pound-foot moved. Pound-foot on number 5. Okay. Unless that was just a freak. No, let's go back down again now, I think. Okay, number 6. AFR. Boost and servo barometer are those two. Number 9. Nothing on number 9. Okie dokie. Let's just do that pounds-foot again. Yeah, number 5. Number 5 is pound-foot. So if I leave that plugged in there, and I put my tongue on the temperature sensor, yeah, that's climbing up. Alright, cool it down. Down it comes again. Cool. So we've got a load sensing going on channel 5. So we've got load and lambda are our 2. Yep, lambda 6, load is 5. Boost. That's working. That's number 7. We've got barometer on number 8. And then on number 9, zippity doodah. Yep, nothing showing there on number 9. Cool. That's all I wanted to do. Excellent. I know, why don't we do another run? Just for fun. Let's see just how much power we can make. Here we go. Right. That should do it. Two 584. So I can just now bring up all 3, I suppose, to look at. Graph background colour. I'm going to make it dark so they show up. There we go. want to get rid of this purple lambda, but it's not obvious how I'm going to do that. Any road up. We have got power curves from our Kenwood Chef, and it's putting out a stonking 3,200 odd pounds for the torque, 223.1, and 2,584 horsepower, which should mix up a mean smoothie, I think it's safe to say. Right, that's it. Signing off. Thanks for watching. Bye.